This conference will now be recorded.
Right, let's start today's session. In the last session of Python, we were discuss about uh, methods, types of methods, and types of variables in Python object-oriented programming class. Like types of variables are instance variables, that is object level, static variables, that is class level, uh, local variables, that is method level. And also we were discuss about instance method, static method, class methods also. And even we were discuss how to access static variables and how to delete them and what happens once we delete the static variables clearly. In today's lecture, I'm going to discuss about few more topics like how to access inner class methods, outer class methods. That means the concept is inner class mechanism. So up to now we were discuss about just how to create a class. Inside a class we included some logic and how to access that logic by using object creation to the class we know. But now I'm trying to introduce inner class mechanism, outer class mechanism. So inner class means generally a class inside another class is called inner class. Sometimes we can create a class inside another class. It is called inner class. Means making dependency with other class is called inner class. For example, you can see without existing one type of object, if there is no chance of existing another type of object, then we go for inner class. So this is inner class. What is inner class means? When we should go for inner class without existing one type of object, if there is no chance of if there is no chance of existing if there is no chance of existing another type of object then we should go for inner class. Then we should go for what class, sir? Inner class. Without existing one type of object, if there is no chance of existing another type of object, then we should go for inner class. For example, you can see class car, and next inside this car class I'm including one more class engine. So this is without existing one type of object, there is no chance of existing another type of object. So in this context we can go for inner class. Means in this is inner class, this is outer class. Inside the car engine is there, so if you want to consult with this one, and you have to consult with this one only. So this class is depending on this one only, just an example. So even you can see without existing one type of object like head, there is no chance of existing brain. You can take any examples like university here, university, and this is what? College. So this is college like this. Without existing of one type of object, there is no chance of existing as another type of object. Without this, we can't imagine this one. Or to consult with this, we can consult first of all this one only. So this is inner class mechanism, but our main motto is, in case if we have a class within the other class, then how to access them. Okay, so that is our main motto. Let me try to access inner class and outer class references clearly. Let's create one more class like object-oriented programming 11. So object-oriented programming 11 class. Now here, what I'm trying to do, I'm taking class. Class is outer. So strictly remember, this outer is not a built-in class which I'm taking here. This just name I'm taking, it's not a built-in class, it's a user-defined class only. Just for as a identification, easily identification purpose, I'm taking this class as outer class only. So class outer only here I'm taking outer, and outer class is having a constructor obviously in it, init. Let's change this code here. Print outer class constructor. Outer class constructor, we can say it. Outer class constructor. It's outer class constructor only. But inside this class, I'm creating one more class, class inner. This name also, it's not a standard name, just I'm taking as per my convenient inner class. And as usual, inner class also I'm including, inside the inner class also I'm including constructor. So inner class constructor, inner class constructor. Inside the inner class I'm taking method. I1 is a method, inner class method. I1 is a method of inner class. So, or else any method name you can take, okay? M1 you can take better, method 1. So this inner class method I'm writing, inner class method. So right now we have a outer class, okay? Class outer. We have a inner class, class outer, and we have a inner class. Inside the outer class, we have a constructor. Inside the inner class, we have a constructor, and also we have a M1 method. Inside the inner class, we have a M1 method also there. So this is M1 method. Done, sir. Now, how I can access this constructor and this constructor and this M1 method also. So first of all, we should create object for what, sir? Outer class. So let's try to create object for outer class. So O is my object name. You can take any object name, it's not an issue. Outer is a class. So when we execute line number 13, O equals to outer. So you know, as per rule of object-oriented programming, as soon as when we create object to the class, who will execute? Constructor will execute. So as soon as when we create object to the class, who will execute? Constructor execute. Which constructor? Outer class constructor. Because I create object for outer class only. Let's hit this run. So I'm taking run object-oriented programming 1 only. Now you can see outer class constructor is executing. Outer class constructor. It's okay. But what about inner class constructor? So we should create object for inner class only. But just observe here, this total portion of the code is belongs to what? This class only. The indentation levels, we can see this here, here. Same level of indentation. This code, how it is belongs to inside the outer class. This total code also line number 6 to line number 11. This total belongs to outer only. So now if you want to access this one as well as this one, you should consult with inner class. But actually, I'm trying to create object for inner class like I equals to inner, but it's not work out, sir. The reason is inner class is not in this indentation level. Inner class is available in this indentation level. Inner class belongs to where actually? Outer only. So without existing one type of object like outer object, there is no existence of inner because it's a inner class mechanism. Inner class is present inside the outer class only. To consult with this one, first you have to consult with this one. How we can consult with this outer class? Because we have object of outer class. So to create object for inner class, so we have to use O reference. O dot inner we have to use. This is the proper way. O equals to outer is okay, but I equals to O dot what? Inner only I'm taking. Now this time I is object reference of what class, sir? Inner class. So once I start run this, now you can see inner class reference is working fine, sir. Outer class constructor, inner class constructor. But what about inner class method M1? So let's try to call the inner class method M1, I dot M1 method. Now you can see I dot M1 method. Got my point? Just to make. Now, so this is I dot M1. So I is a object reference of inner class. So that's what M1 method we should call with the help of I dot M1 only. So let's run this. Now you can see outer class constructor, inner class constructor, inner class method. So all are coming. So this is the way to access if we have a class within the class like this one. But observe here, I'm commenting this all three lines, select all three lines and control forward slash. So this is commented out. Okay. Now, this time you can see I'm trying to create uh, only one object for the outer and inner object. Suppose O equals to outer dot inner. So when we create object for this outer class as well as inner class at same time, so both constructors are going to be executed, sir. Okay, O equals to only one object reference of outer of inner only. So outer class constructor executed, inner class constructor executed because of line number 17. Only one reference I am giving outer dot inner because inner is present inside the outer only. Outer dot inner we can use. In case if you want to call this O dot M1 method, then we can use this O dot M1 also. M1 method also will be there. So either you can go through line number 13, 14, 15, or you can go through line number 17 and 18 also. Both result are same. Now let's comment these two lines also. Let's comment these two lines. Now you can see this. Without the object directly, I'm trying to create references inner dot M1 only. So once I run this, this will also work same as our result is same. So all options I am showing like how we can able to access the functionality. So outer dot inner dot M1, outer dot inner dot M1 method. So outer class, inner class reference and M1 method here. This is also fine. But all the time it may not work out well, sir, in this case. Okay. Why it not work out? I'll tell you. In case outer class also is having some method like TF F1 method is there. But this time I'm including here outer class method. Outer class method. So F1 method is belongs to what class, sir? Outer class only. So M1 methods belongs to inner class. If I want to access outer class method, what we need to do? Okay. So outer dot F1 dot like this. Outer dot F1 dot. Okay, just see this. F1 dot inner dot M1 will not work. This is not correct way. Outer dot F1 dot inner dot M1 will not work. You can see this if I'm giving non-type object has no attribute inner. This is not correct way because inside the class we can represent one more class. Inside the class F1. F1 inside inner method not. Okay. So that is not correct. So to access outer class inner class M1. At this moment, outer class constructor executed, inner class constructor executed, inner class method is there. But if you want to access outer class method, again, outer dot F1 separately how to use. But in this context, what will happen? Two times constructor is executed or not? Line number 23, outer class constructor execute, line number 24, outer class constructor and outer class method only. So that's not good idea again. Look at here, outer class constructor, because of this, inner class constructor, because of this, inner class method because of this. Again, outer class constructor and outer class method. This is not good approach when we have your outer class also having method. So that's what you just commented. And which is the best approach means this is the best approach, sir, actually. But in this approach also you can see O equals to outer class object reference here, but still O dot M1, O dot F1 I'm taking here. So look at here O dot M1, O dot F1. Is this valid or not? You can check once. Now you can see it's not a valid. Why? Because O dot M1 is okay because O is object reference of outer, outer is having inner, inner is having M1. but O is not directly available, what we can say, F1 only, because O is object reference outer and inner, both it is there, but F1 we cannot call directly. Okay, so even if we try to do like this, just observe, this is not correct way, sir, because O is maintaining reference from both classes, but it's not possible to access here F1. Did you mean M1? Yes, M1 only. M1 will work. So this is the problem actually. This case is not working well when we have outer class is having one more sorry, inner class, outer class is having one more method. Now this approach is the best approach, sir, because you created separately O equal to outer object, so O dot F1 is possible. And also we created I object is separately with help of O reference inner, I dot M1 is possible, sir. Now you can see both are possible. Outer class constructor because of this one. Outer class method because of this one. O dot F1. Inner class, what we can say, constructors, inner class method. This is individual reference through I am maintaining. So this is the way to consume or access if we have a class inside another class. So you can include any number of constructors, any number of methods inside another class. This is the way to access clearly here. Okay, so that's all. And next I'm trying to discuss another important topic apart from inner class and outer class. This is just an example in case if you have any, sir, can we create multiple constructor in a single class? Yes, we can create, but last constructor only will execute, sir. This is under comes into constructor overloading. This is our polymorphism feature actually. In upcoming session, we'll discuss. Even we have not started object-oriented programming features, So I have to start with encapsulation, inheritance, polymorphism, abstraction like that. So your question is, okay, you can include multiple constructors, but actually in Python, when we include multiple constructor in one class, look at here. Last constructor only is going to be considered, I'm saying, because the reason is constructor overloading is not there in Python. Okay, so outer class constructor 1 I'm taking. Now this is outer class constructor 2 I'm taking. Result is obviously you will get what? Outer constructor 2 only, not both. Not both. Because constructor overloading is not possible in Python. Let's see this. Only we will get one constructor, that is recent call. What constructor? Outer class constructor 2, not outer class constructor 1. We can include. But multiple constructor will not work at once. This and this both you want, you cannot. Because recent call only. Why recent call? Because it's an interpreter. Interpreter means what? First it will go and later it will go. Latest one, which one is this one only? This one will execute. Got my point? Yeah. I'll give more clarity about why not overloading of the constructor and even why not overloading of the methods also in upcoming session at the time of polymorphism. You will get clearly. Okay. So now coming to this GC. So as I said that in my introduction session of Python, GC means garbage collector. I can say that. GC means what, sir? Garbage collector. What is garbage collector? What is the use of garbage collector? A garbage collector is used to provide automatic memory management. Automatic memory management, sir. What is the use of garbage collector? Garbage collector is used to provide automatic memory management. Sir, what is automatic memory management generally? In general, in any programming language, like including C++, Java, C#, .NET, Python, JavaScript, anyway, generally we used to create objects. All the time, objects are two types. One is objects in use. These are useful objects to run your application. Next one is idled objects. Idled objects means what actually? Garbage objects only. Idled means no use. Ideally sit back in the memory. Okay, unnecessarily it's occupying the memory. That is called idled objects. So when we are working with application, generally we will create lot of objects. In that process, when we create objects, some objects are objects in use, that means useful objects. Some objects are idled objects, that means not useful objects. Obviously, obviously objects in use we should kept in the memory. Idled objects you should destroyed from the memory, because idled objects means garbage objects. Unnecessarily that objects are created and occupy the memory. So that type of objects are garbage objects or unused objects that should be removed. So automatic memory management is the process of providing memory to the objects in use and deallocate memory for the idled objects. Later, we can destroy these garbage objects or idled objects. This process is called automatic memory management. So who will provide automatic memory management in Python? Garbage collector. Because as I said that in the introduction to Python, Python is a high level programming language. That means you need not to take care any activities for low level. So internal process purpose, no need to write any explicit logic as a programmer. So automatically Python garbage collector will take care memory management. So no need to write any explicit memory code. Even we discuss many programs up to now, but nowhere I have written any memory logic for our application code. The reason is what, sir? Actually, it's a automatic memory management process is there in Python. That is garbage collector. So, sir, what happen if there is no garbage collector available in our Python code? See, if there is no garbage collector available, so when we create objects to the class, automatically objects we can create, that objects will occupy the memory. So no one is there for doing cleanup activities, means memory deallocation process purpose, and your objects keep on occupy the memory. But always, if you keep on executing the program, sometimes your application will be run out of the memory. Means you will face memory issues because insufficient memory issues, no one was there for cleanup activities. So that's what insufficient memories occurred, obviously. So this is the problem. To avoid this problem, always in Python programming, every program garbage collector is in active mode only. That garbage collector will take care that memory management. Whenever the objects are needed any memory, garbage collector will allot the memory. Whenever the objects are not useful, that is garbage, that means the objects which is don't have any reference, that objects are eligible to garbage collection. So that objects can be destroyed from the memory after performing the deallocation process. So this is exactly how garbage collector will work. First, let me check every program. As I said that every program is having garbage collector internally. How do we check, sir, whether the Python program is using garbage collector or not, whether it is there or not? How to check? Simple. There are some methods are there, especially to check whether garbage collector is there or not. Okay. So these methods are, one method is enabled method is there. This method is going to return true or false. If the garbage collector is already in active mode, like means enabled, this method will return true. True means garbage collector is enabled. This method is used to check whether garbage collector is enabled or not. Next, if you want to disable the garbage collector explicitly, disable method is there. This method is for what purpose? To disable garbage collector explicitly. To disable garbage collector explicitly. Next, again, if you want to enable the garbage collector, you can use enable method is there. So what is the enable method? You can see to enable garbage collector explicitly. To enable garbage collector explicitly. All three methods is enabled method, disable method, enable method. All three methods are present in a module called GC module. So GC is a built-in module, that is garbage collector module. To work with excuse me, to work with these three methods, is enabled or disable and enable method, we have to use GC garbage collector module. Otherwise, these methods will not work out. Let's quickly check in my program garbage collector is active or not. How to deactive? We'll look into one simple example here. Object oriented programming 12. Now this time you can see import GC. GC is a garbage collector module. And now I am checking in this program, like test object oriented programming 12.py program, whether the garbage collector is active mode or not. So is enabled method through I'm checking. If your program is having garbage collector, obviously your program will return this is enabled method will return or true only. Now you can see it's written true or not. Yes, it returned true. That means by default in every Python program, garbage collector is in active mode only, sir. That's what gc.isEnabled method return simply true only. Let's make disable garbage collector explicitly. Now you can see gc.disable I'm taking. Once I use this disable method, automatically we can explicitly disable the garbage collector. But how do we know whether it is disabled or not? Simply you can copy this line and paste into here, and again you can see this method is disabled. Print gc.isEnabled method, it return true only. Sorry, false only, because already we deactivate the garbage collector. First it's true and we disable, after that it enable. Next to what I'm taking, gc.enable method I'm taking. Now print gc. Is enabled method I'm checking. After enable, you have to check whether it is enabled or not. Now you can see true, false, true only. True means it's by default enabled. After disabling, I'm checking false, it's disabled. After disabling, I'm enabling this garbage collector. Now gc. Is enabled, true only, like this. This is case. Okay. Import gc. Is enabled, gc.disable, gc.isEnable, gc.enable, like this. These are the methods just for cross verify your Python program is having garbage collector in active mode or not. We can cross verify this. And most importantly, I want to introduce in this garbage collector mechanism one more important method that is called destructor. You know about constructor? So constructor is a special method of class. The constructor name is what actually underscore underscore init underscore underscore self. Same, we have a destructor. So what is destructor means? Destructor is a special method of class. Destructor is a special method of class, and the destructor name is destructor name is and the destructor name is underscore underscore del underscore underscore of self. So you know constructor name underscore underscore init underscore underscore. Init means initialization, means construct. Del means delete, means destruct. Always destructor name is in Python underscore underscore del underscore underscore only. Yes. So the destructor name is this one. What is the use of destructor? Who will call exactly destructor? See, garbage collector will call a destructor for what purpose? Not for destroying the objects, sir. Okay, don't think so. Destructor is for destroy the objects only. No. Garbage collector will call a destructor for cleanup activities. For what activities, sir? Cleanup activities only. Cleanup activities means what actually? Memory deallocation process. Memory deallocation process. So cleanup activities means what actually? Memory deallocation process, sir. Deallocation process. Memory deallocation process is not meaning of destroy the objects. Okay, for your kind information. Garbage collector will call a destructor for what purpose? Cleanup activities. Cleanup activities means memory deallocation process. Once garbage collector uh, will call destructor, destructor responsibility is what? Only cleanup cleanup activities should be performed. That means memory deallocation. But once destructor execution completes, means cleanup activities finish, then garbage collector only will destroy the objects. So question is, who will destroy the objects? Your answer is garbage collector will destroy the objects. When garbage collector will destroy the objects? After completion of destructor execution. Who will call destructor? Garbage collector will call destructor. For what purpose? Cleanup activities purpose. So the role of destructor in garbage collector is only to perform cleanup activities, that is memory deallocation process. And the garbage collector never destroy the objects. Sorry. Destructor will never destroy the objects. Who will destroy the object after completion of destructor execution? Means deallocation process is over, then garbage collector will destroy the objects only. This is the process happen. But as of now, we don't know in our Python programming destructor is available or not. Yes or no? So let me introduce just destructor for simple program, because you have to know how destructor will work actually. Let's create one class called test. And inside the class, I'm taking what actually? Constructor. So now you can see constructor execution. Constructor execution. Okay. Now let's create object to the class t equal to test. And whenever we are making t equals to none, means nothing is there, because when the object reference is not there, then this object will eligible for destructor only, because memory cleanup activity is required for them. Now you can see I'm printing the program, just end of the program I'm taking, end of the program. So now let's run this. So constructor execution, end of the program. But before that end of the program, destructor also executed. Now you can see right now we don't have destructor. That's what you don't know whether destructor is executed or not. Now I'm including destructor execution. Now you can see destructor execution. Let's run this. Destructor also executed here. Constructor immediately after destructor is there, because once constructor is okay, when we create object to the class, constructor executes. Whenever we are making this t equal to none, means so this t object reference is not there. Whenever this object is don't have any reference, then automatically this object is eligible for garbage collection, means memory cleanup activity, and destroy. So who will execute destruction? Garbage collector will call destructor method for this object reference after that end of the program. So just I'm including destructor because of you, to show that whether destructor will is there or not, and destructor will execute or not automatically. So always destructor is follow constructor only. Sorry, constructor will follow destructor. First constructor, then destructor automatically. But we don't know whether it's executing or not internally up to now. Previous programs also, every program destructor is there. So who will call destructor? Garbage collector will call destructor. For what purpose? Memory cleanup activities purpose. But just for showing you, I included here in this program destructor method also, whether it is working or not. Okay. So these are all about basic programming of object-oriented basics only, object-oriented programming basics only. Now it's time to begin with our features like encapsulation, polymorphism, inheritance, abstraction. All these features we have to discuss. Okay. First, we'll start with encapsulation. Before encapsulation, I need to give some clarity on the variables and methods. So according to Java as well as C#.NET, other languages. So if in Java or C#.NET, other languages, if they want to make a variables and methods are private, so they're having private variables, private methods, public variables, public methods, protected variables, protected method, like that only. But in Python, that kind of things are not there. No private, public, protected. There is no access modifiers in Python. But we can represent the variables and methods are private, public, like that. But by default in Python, all variables, all methods are public only. Because in Python, the variable which is not starts with any underscores, or the method which is not starts with any underscore, that is called what actually by default? Public only. So all variables and all methods in Python programming language is public. But how to declare the variable as private? Let's see this. Suppose x equals to 10. This variable is don't have any underscore starts with. This is called what variable? You can say public variable. The variable, once it is starts with single underscore, y equals to 20. This is actually protected. Just name convention I'm taking protected, but actually this is also private, but not strongly private. So next, the variable which is starts with double underscore like z equals to 30. This is strongly private, sir, actually. So private variables can only be accessed where we declare, in which class you declare, on that particular class only we can access private variables, sir. Public variables, anywhere we can access, there is no restriction on public variables, sir, because this is public property, anyone can use. No, private property, only the uh, restricted persons, means which person is the owner, that person only can able to access. Protected means some semi restriction is there, owner and owner related members also can be used that property, that is protected. Just imagine. So in other languages, if they want to declare any private variables, even in C sharp or Java, we can declare like this: private int empid, like this. Access modifiers are there, but in Python, no. So symbolically we can declare the variables and methods are private or public or protected. How to recognize public variables or public method? A method which is not starts with any underscore, or method which is any variable which is not starts with an underscore, that is called public. A method or variable starts with single underscore, that is protected. A method or variable starts with double underscore, that is called private. Private, fully restriction, where you declare there only we can access, outside the class we cannot access private variables. Public means fully permission, no restriction, within the class, outside the class, anywhere we can access. But protected is there. No, protected is semi restriction. Suppose if you have a parent class and child class, inside the parent class I included protected. This protected variable can be able to access the child class also, which is inherited from the parent. That is possible. But private is there. No, even though parent class is having private member, child can never access. Even though child is inherited from the parent also, it's not possible, sir. That is strongly restricted. Let's see the quick example about this so that you'll understand. So let's add one new file here. Object oriented programming 13, sir. Now let's create a class. Suppose I'm creating class test. Now you can see this, I'm declaring one variable x value 10. This is what actually, what variable? Public variable. And underscore y equals to 20. This is what variable? Protected variable. Protected. Underscore z equal to 30. This is what variable? Private variable. So inside the class I'm trying to access, just I'm taking constructor, because constructor is a part of my test class only. Can I access here self.x? Yes, why not? Public variable can access here. Can I access self.underscore y? Yes, why not? It is also possible. Can I access self.underscore z? Yes, not possible, sir. Because we are in the within the class, that means constructor inside only. We can access within the class whatever we declare. Public variable can access, protected variable can access, and private variable also can access. Possible. So let's try to create object to the class. Automatically constructor will execute. Inside the constructor I'm printing all the variables: private variables, public variables, protected variables. Happily you can access, sir, no problem at all. Within the class is okay. So let's give the clarity just by printing within the class. Within the class only. But now what about outside the class? This is the outside the class. Outside of the class. So outside of the class means self will not work, as you know that. Outside of the class, which is work? Only object reference will work. So object reference means what? T. T dot X. Is this possible or not? X. Yes, sir. X is a possibility is there because it's a public variable. We can access outside the class. Underscore Y is also possible or not? Yes, it is possible, sir, because it's a semi restriction. Now outside the class, X value is possible 10, Y value is possible 20. But just to try to access outside the class underscore Z. So Z is a private variable because it starts with two underscore. Now whenever I try to include t dot z, then we got the error called attribute error. Test object has no attribute underscore z, because underscore z is a what variable? Private variable. But we are trying to access them into outside the class. Private variables can only be accessed within the same class where we declare. Outside the class, no possibility. This is the clear idea which I'm giving you. This is one simple example which I'm taking. But still, parent and child related through, I will show you private and public methods, protected variables, how it will work. Let's quickly show the one more example, object-oriented programming 14. Now this time I'm taking parent class. Inside the parent class, I'm declaring public variable. It's okay. Protected variable. This is protected variable. The variable which starts with single underscore, protected variable. Now you can see underscore underscore z equals to 30. What actually? Private variable. Now class, this is parent class. Let's go for child class. Inheritance process. This is just I'm showing as an example. So inheritance is actually, this is only in Python. In upcoming session, you will also come to know what is inheritance, how to work with them. So this is child class, which is inherited from parent class. So basic purpose of inheritance, that in inheritance process, automatically child class will get all the features from parent class only. Yes or no? Child class will get all features from parent class. So in the child, I'm accessing with parent class only. Parent.x, is this possible or not? Yes, sir. Why not? Parent.x means parent class onwards, x value I'm accessing because it's a public variable, x variable. Fine, 10 is working fine. But even protected variable also we can access or not? Yes, sir. Protected variable also we can access. Parent underscore y. That's possible. But look at here, underscore underscore z is a private variable. This private variable, even though this child is inherited from its parent, but still private variable not possible because it's a strongly private. Private means private only. No parent, no child relation. So we are trying to access, but it will give error, sir. Attribute error again. Type object parent has no attribute underscore child underscore underscore z. No possibility is there. Okay, no possibility is there. So this is called strongly private. So based on this private variables and public variables, through only I'm going to explain encapsulation. What is encapsulation? I said in the beginning of object oriented programming. Encapsulation is the process of providing restriction to access variables and methods. Encapsulation is the process of what? Providing restriction to access variables and methods. Why we need encapsulation means, why we need encapsulation means to prevent the data from modification. To prevent the data from modification. Why we need encapsulation means to prevent the data from modification. If someone is trying to attempt to access your variable or trying to attempt to modify your variable data or method implementation, then we should provide restrictions on them. So by making what? Variables and methods are private. How do we achieve the encapsulation mechanism means? So we can achieve the encapsulation mechanism by making variables and methods are private only. So once we make our variables and methods are private, that is only eligible to access inside the class, not outside of the class only. So in that way, if someone is trying to modify your variable data, if someone is trying to, what we can say, change your functionality wantedly or accidentally, then that impact should not be there on your variables and methods. In that context, we can go for encapsulation. So by making our variables methods are private. So I'll show you clear examples in tomorrow's session, what exactly encapsulation, variables through and methods through. Both through, I'll explain the logic clearly. So tomorrow we'll start with our programming, object-oriented programming features like encapsulation, polymorphism, abstraction, inheritance, all the features will begin with. So up to now, whatever we discussed, only basics of object-oriented programming. Types of variables, types of methods, garbage collector, inner class, outer class mechanism, private variables, public variables, protected variables. Okay. So this underscore symbols not only for variables, for it's applicable for methods also. A method starts with double underscore or single underscore, that also will become private and protected. No underscore means public methods only, like that. Okay. So rest of the things we'll discuss in tomorrow, sir. You can use this link next 2 weeks also. This week and next week also completely you can use this link only.